there is an infinitely long conducting wire which has been bent in this manner, and the radius of this part, of this bent part, is r. Is a half circle, and current is flowing in this manner. Okay, so now at this point P, you have to calculate the magnetic field. Now very clearly you have three segments, number 1, number 2, and number 3, and I just want to write down the magnetic fields due to these three parts one by one. Okay, so and then I will just do the addition or subtraction depending upon the direction of the magnetic field. Clearly, so now for point number 1, at the magnetic field at point P should be, now it is very clear that it will be mu naught by 4 pi I, current is I by, what is the distance from point P from of this part, I by r, sine theta 1 plus sine theta 2, right? So obviously this part is sine 0 degree, and the another part is infinitely long, so the angle is going to be 90 degree. So clearly it will become sine 0 plus sine 90 degree. So it is coming out to be mu naught I by 4 pi r. But important thing is that the direction, what is the direction? So for that you have to do I cross dl. Now I is along this direction is IL, isn't it? So along this direction is IL, and this is the direction of dl, and this is the direction of r, isn't it? So you have to do dl cross r. Are you getting this? So for dl cross r you have to do this thing. So I cannot show it properly to you, that if you just do dl cross r, automatically it will come into the plane. Okay, so the direction will be simply into the page. Okay, the direction is simply into the page if you just do the dl cross r. If you just do dl cross r, and it will be automatically just put the hand like that, and just curl your hand around the r vector. It will be, your thumb will your thumb will indicate along the into the page. So automatically it will be, the direction will be cross. Okay, and now what will be the direction due to the option along the 2? So for the portion 2, very clearly the magnetic field will become what? Tell me. Okay, so due to the second part, since this is a half circle, so the formula will be mu naught I by 2r, but into half, right? You have to multiply it by half because it is a half circle. So ultimately it is coming out to be mu naught I by 4r. But what is the direction? To find out the direction, just place the hand along the loop just like that, and your thumb will indicate away from the page. So it will be away from the page, isn't it? And finally, what about the part 3? Due to the part 3, the magnetic field will become, it is again the same infinitely long wire, and the value will be exactly again mu naught I by 4 pi r, just like the segment 1, but the direction is again cross y. Again you do just the I cross r, and it will again show you the direction of into the page. Okay, so if I just want to calculate the net magnetic field, B net, so you can see that 1 and 3 both are so B1 and B3 both are directed into the plane, so they will be added up, and the B2 is away from the plane, so obviously you have to subtract it, isn't it? So now obviously you can see that this one is greater, so the net magnetic field will be mu naught I by 4r minus mu naught I by 4 pi r multiplied by 2, because B1 and B3 will be added up. Okay, so this will be your net magnetic field. So it is coming out to be mu naught I by 4r 1 into 2 by pi. Okay, so this is coming out to be the B net. But what will be the net direction? Obviously, since mu naught I by 4r or the B2 is greater and it is directed away from the page, so the net magnetic field will be also directed away from the page. Is that very clear? So that is why it will be away from the page. Clear? So that means your correct option is which one? Mu naught I by 4r, but it is directed away from the page. That means option 2 is the correct option. Okay, now come to the next one. Question number 46. Question number 46 is saying that the resistance of a platinum wire at 0 degree Celsius is 2 ohm and 6.8 ohm at 80 degrees Celsius. The temperature coefficient of the resistance of the wire is, so you know probably this relation, that RT equals to R naught into 1 plus alpha into delta T, where the RT denotes the resistance at T degree Celsius, R naught denotes the resistance at 0 degree Celsius, and obviously the alpha is the, what is alpha, tell me, see, and we actually want the alpha in the question, so this is the coefficient of resistance of the wire. Okay, so this is the coefficient of resistance, and del T obviously it is denoting the change in temperature. Okay, so now according to your question, the RT is, that means at 80 degrees Celsius it is 6.8 ohm. Okay, so RT is 6.8 ohm. What is R0? That is the resistance at 0 degree Celsius is given to be 2 ohm. So this is 2 plus 1 plus alpha we need, and what is del T? Obviously that will be 80 minus 0, and just you have to solve for alpha. So this is 3.4 equals to 1 plus 80 alpha. So 80 alpha is coming out to be 2.4, and alpha is coming out to be 2.4 by 80. So this is 0.03. Okay, if I am not very wrong. So this is coming out to be 0.03 or 3 into 10 to the power minus 2 degree per degree Celsius, isn't it? Okay, so this is coming out to be option 2. Okay, 3 into 10 to the power minus 2 degrees degrees per degree Celsius. Okay, so now come to the question. Next question, question number 47. Question number 47. In question number 47, electric dipole has been given of length 6 cm, and you have been asked to find out the electric potential at the point P. So this is actually a very simple question. An electric potential has been asked to find out in 10 to the power 2 or 10 square volt. Okay, just let me erase this part, and let me write it here itself. So the given situation is like that: minus Q and plus Q, two charges are given, and this is the point O, this is the distance 3 cm, and this is the distance in another 3 cm, and I have to calculate the potential at this particular point P. Okay, and now this is, what is this? This is the 5 cm. Okay, so very clearly, if I just want to calculate the distance of the point P from the both the charges, so obviously this is coming out to be how much? 5 minus 3, that means 2 cm, and from this charge the distance is coming out to be 5 plus 3, that means 8 cm. Very good. Now you have to simply calculate the potential at the point P. So the potential at the point P will be, due to the minus Q charge, I think it will be minus KQ divided by 8 cm, but you have to understand that you have to convert it into meter, because you have been asked to clearly in the question to calculate the potential in volt. Okay, so automatically it will be 3 into 10 to the power minus 2. So automatically it will come above and as 10 to the power minus 10 square, and plus, now due to the plus Q charge, it will be KQ divided by the distance is 2 cm. So 2 into 10 to the power minus 2 meter, and 10 to the power minus 2 meter means it will come above and it will become 10 square volt. Okay, is that clear? So it will automatically become, just KQ, just take 10 square volt common, and you have to give the answer in simply minus KQ by 3 plus KQ by 2. Okay, clear? And it is coming out to be how much then? Then it is coming out to be 3 by 8 UK 10 square volt. So your answer is clearly which one? So your answer is coming out to be 3 by 8 UK. Okay. Okay, so come to the next question. So such a in this particular figure, what will be the equivalent focal length for the combination of lenses? So I already told you in a previous question that the formula of the combination of the lenses becomes what? 1 by f equivalent will be equal to 1 by f1 plus 1 by f2 plus 1 by f3 plus dot dot and so on. So now the same thing happens here also. Basically there are 3 type of lenses. You have to understand that in such a combination, when such a combination is given, so basically this is a biconcave lens sorry, it is a biconvex lens, and this is a plano-convex, and this is a plano-convex lens. Is that clear? So now come to one by one, because in your question directly the focal length is not given, and you have to calculate that by using the different formulas from the lens maker formula, particularly for being more specifically. So when a biconvex lens is given, where R1 and R2 are the two radius of curvature of the two surfaces, and mu is the refractive index of the lens, then for particularly when R1 is equal to R2, that means for a biconvex lens, when R1 equals to R2 equals to R, then in that particular case the focal length of the biconvex lens is actually becomes equal to R by 2 into mu minus 1. You should know this for particular formula. This is simply coming from the mu lens maker formula itself, okay, and nothing new. If you just put the values here, then it will come out to be, this is 20 divided by 2 into 1.5 minus 1. So this is coming out to be 10 by 0.5, and this is coming out to be how much? 20 centimeter. So the biconvex lens is actually having the focal length 20 centimeter, okay. And now what about the two plano-concave lens on both side of the biconvex lens? So I will just calculate the focal length of one, and that will be also equal to that will be also valid for the another one also. So for such a plano-concave lens, the focal length actually becomes R divided by mu minus 1, okay, simple. Now what about R? R is nothing but also 20 here, and mu will be how much? Mu is nothing but 1.6, it is given. So 1.6 minus 1, and it is coming out to be 20 by 0.6, okay. So this is 200 by 6 or 100 by 3, okay. So this is coming out to be 100 by 3 centimeter. This is the f2, clear, and that was the f1, okay na. So very clear, mostly. So this is f2 also, and just 1 minute. Suppose this is 2 and this is 3 and this is 1, so this is f3 also, right? So the net equivalent f will be 1 by f1 plus 1 by f2 plus 1 by f3, okay. So now, okay, so what will be the, just putting the values. 1 by f1 is actually 1 by 20, but here you know that, okay, for plano-concave lens the focal length is always negative, so this is actually coming out to be 1 by 100 by 3 multiplied by 2, because f2 and f1 are both same basically. So then it is coming out to be 1 by 20 minus 6 by 100, okay. So this is 1 by f equivalent, so this is coming out to be 100, 5 minus 6, so minus 1 by 100, 1 by f equivalent. So finally tell me what is your f equivalent? Is actually minus 100 centimeter, clear. So the f equivalent is coming out to be minus 100 centimeter, clear. So option 2 is the correct option, clear. Okay, now come to the next question. Next question is a very good question, that a wire is carrying a current I along the positive x-axis, okay. Just let me erase this. So now it is kept in a magnetic field V equals to 2y plus 3j minus 4k Tesla, the magnitude of the magnetic force acting on the wire. So let me simplify the problem. So basically there was a wire given like that, and it is carrying a current I, and the length of this wire is L simply, and it is within the magnetic field. So in this region a magnetic field exists which is given as 2i cap plus 3j cap minus 4k cap. Simple, right? This much Tesla. Now the question becomes, so what will be the magnitude of the magnetic force acting on the wire? Now you simply know that in such a case the force always acting on the current carrying wire is given as the F is equals to I into L. So I am simply like writing it down to be L cross B, isn't it? Now you know here the current is I, it is given. Now what is L? Now simply try to understand the magnitude is L, and this is directed along the positive x-axis. So can I write it down to be L I cap? Will that be clear? Cross it will be 2I plus 3J minus 4K cap. Clear? Okay, now you have to do the cross product very cautiously. Okay, now try to understand. Obviously I cross I will be 0 because the angle will be 0, so I'll not take that. Rather it will become 3L I cross J, it will become K cap, and then it will become 4L, but I cross minus K, what it gives, if you do I cross K, then it will give minus J, so automatically it will become plus J cap. Okay, so this is coming out to be the vector form of the force. Okay, this is a vector form of the force, but they have asked for the only the magnitude. Since they have asked for the magnitude only, so the magnitude will become I into root over of 3L whole square plus 4L whole square, and that will be obviously only 5L. Okay, so tell me what will be the magnitude. The magnitude will be 5L. Clear? Now come to the last question, which is a good question according to me. Now the next question was a x versus t graph for a particle performing a simple harmonic motion is shown in the figure. The acceleration of the particle at t equals to 2 seconds is. Now try to understand that this question can be solved in many ways, but if I just want to if I just ask you that, okay, what will be the equation of this graph, can you show that, can you see that this is a sine function starting from the 0, so is it, and can you appreciate that, okay, the amplitude is how much? The amplitude is actually 1. So can I write down the equation to be like that, that it is x equals to, what is a is nothing but 1, right? 1 sine. Now tell me what is omega t, because this is what will be omega. Obviously you can say that what is the time period. Can you appreciate that the time period is actually how much? 8 seconds. So the omega will be 2 pi by 8, isn't it? Because omega is 2 pi by time period. Here the time period is nothing but 8 seconds. So this is 2 pi by omega into t. Clear? So this is coming out to be the equation of the motion. So this is your x, isn't it? Now you tell me that if it is so, then acceleration, you know that acceleration can be written as minus omega square x. You know this, right? Now, minus omega square x. Now what is omega? Omega is 2 pi by 8 whole square. And what is x? Now try to understand. You have been asked to find out the acceleration, particularly at t equals to 2 seconds. So at 2 seconds, I think the x will be sine 2 pi by 8 multiplied by 2. That means simply it will become sine pi by 2, or sine pi by 2 is nothing but 1. So this is actually coming out to be 1. If you just put, because acceleration at time t equals to 2 will be only at when you will put the value of x at particular time t equals to 2 seconds, and this is nothing but 1. So this is minus pi by 4 whole square multiplied by 1 meter per second square. It will become minus pi square by 16 meter per second square. Okay, so this is coming out to be this one. Okay, so your correct option is, this will be negative obviously, so this will be minus 16 pi square by 16 meter per second square. Okay, so these were all the questions of the section B physics in Neet 2023, which I discussed. So that's all. Now I'll be solving the rest of the questions of the group A in my next video.